Today our question is, what is Doppler effect? Obtain an expression for the apparent frequency of sound heard when the source is in motion with respect to an observer at rest. This is an essay question, belongs to waves lesson. Okay. What is Doppler effect? We have to derive an expression when source is in motion and observer is at rest. Okay. The definition: the apparent change in frequency of sound of source due to relative motion between source and observer is known as Doppler effect. So here this is apparent change. Apparent means not actual. It appears like that. The apparent change in frequency. There is a source. The source releases sound. There is an observer. Due to motion of source, that means the source is coming towards the observer or the source is moving away from the observer, the sound may be increased or decreased. So that is called apparent change. So now the expression for apparent frequency when source is in motion and observer at rest. So first we have to derive the expression. When source is moving and observer is not moving, means observer is at rest. For that we have to write, consider source S and observer O are separated by a distance L. Let source releases sound of frequency N and V be the velocity of the sound. So first case, observer at rest, source is moving towards the observer. Okay, let us suppose this is source, this is observer or listener. Okay, so the distance between source and observer is L. This is L. Source is moving towards the observer. So suppose source moved or displaced at a certain distance, that is this S dash location, with velocity Vs in this direction. So the displacement of the source can be expressed in terms of velocity of source into time. So velocity of source into time means the velocity Lt power minus 1 into t. This t and this t gets cancelled. The answer is L. So this refers the length. Now the remaining distance, the distance between S dash and O, will be L minus Vs to t. So here, according to this diagram, the source is moving with velocity Vs. Here the source releases a first crust at the location S. After certain time it releases second crust. At the time of second crust releases, it was displaced to certain distance. Okay, so now the source releases first crust, the frequency received by observer after time t1 second, that is t1 is equals to L by V, L by V, where V is equal to velocity of sound in air. This is equation number 1. Next, after that, observer received second crust. Observer received second crust. This is first crust. This is first crust after T time. Then this is T2 is equal to capital T plus this value, this is L minus VST divided by V. So here small t refers the time gap between crust to crust. This capital T refers the time taken to displace the source. Okay, so now simplify this equation. We get this is equation 2. Find the time difference, that is T dash is equal to T2 minus T1. So T dash is equal to T2 means T plus L minus VST by V minus L by V, that is equal to T plus, now separate these terms, L by V minus VST by V minus L by V. This L by V and this L by V gets cancelled. L means length, V means velocity of sound in air, that will be 330 meter per second to 340 meter per second. So T dash is equal to T this minus VST by V. So take common factor of T. T dash is equal to T into 1 minus Vs by V. Now simplify this. It is equal to T into V into 1 V minus Vs by V T dash. Now we have to find the frequency, apparent frequency. We have to find apparent frequency. For a frequency, the formula is frequency is equal to 1 by time. So we have to write this equation in reciprocal form. So 1 by T dash is equal to 1 by T into V by V minus Vs. So but 1 by time means frequency, that is N. So N is equal to 1 by T. So this is T dash means we can write N dash, apparent frequency, that is into N into V by V minus Vs. Okay, in some textbooks N can be taken as F or N something or nu. So this is the final expression for the apparent frequency of the sound when the source is moving towards the observer. Okay, next condition, when the source is moving away from the observer. When source is moving away from the observer, then the apparent frequency n dash is equal to n into v by v plus vs. So this is the second condition or second case. Okay, so source is moving away from, by modifying this equation we can get this condition. Okay, this is an essay question, of course important for intermediate and important for NEET and mains. Okay, thank you.